Welcome to our comprehensive guide on sound for ICSE Class 10. In this video, we'll explore the fascinating world of sound, how it's produced, how it travels, and how we perceive it. Sound is an essential part of our daily lives, from the music we enjoy to the conversations we have. Understanding the science behind sound not only helps you score well in exams, but also deepens your appreciation for the world around you. Let's begin our journey by understanding what sound actually is and why it matters in both science and everyday life. Sound is a form of energy that travels in waves. It is produced when an object vibrates, causing the surrounding medium, usually air, to vibrate as well. These vibrations travel as waves and reach our ears, allowing us to hear. Whether it's the strum of a guitar or the ring of a bell, all sounds start with vibrations. In this section, we'll break down the basic definition of sound and set the stage for deeper exploration into its properties and behavior. Every sound we hear begins with a vibration. When you pluck a guitar string, hit a drum, or even speak, you create vibrations. These vibrations disturb the particles in the surrounding medium, setting off a chain reaction. The particles bump into each other, passing the energy along in the form of a wave. This process is fundamental to understanding how sound is produced and why different objects create different sounds. Let's look at some everyday examples to see this in action. Sound is produced, it needs a medium to travel through. This medium can be solid, liquid, or gas. In air, sound travels as a longitudinal wave, where particles move back and forth in the direction of the wave. In solids and liquids, sound can travel even faster because particles are closer together. Understanding how sound propagates helps explain why we hear echoes in empty rooms or why sound is muffled underwater. Let's explore how sound moves from one place to another. Sound waves are a special type of wave called longitudinal waves. In these waves, the particles of the medium move parallel to the direction of the wave. This is different from transverse waves, where particles move perpendicular to the wave direction. In sound, areas where particles are close together are called compressions, and areas where they are spread out are called rarefactions. This pattern repeats as the wave travels, carrying sound energy to our ears. It's important to distinguish between transverse and longitudinal waves. While sound travels as a longitudinal wave, light and water waves are transverse. In transverse waves, the motion of particles is at right angles to the direction of the wave, like ripples on a pond. In contrast, sound waves push and pull particles in the same direction as the wave travels. This difference affects how energy is transferred and how we experience different types of wave. Speed at which sound travels depends on the medium. In air at room temperature, sound travels at about 343 meters per second. In water, it's much faster, and in solids, it's even quicker. This is because particles in solids are packed closely together, making it easier for vibrations to pass from one particle to the next. Factors like temperature, humidity, and the type of material all influence the speed of sound. When sound waves hit a surface, they can bounce back just like a ball bouncing off a wall. This is called the reflection of sound. Echoes are a common example of this phenomenon. In large empty spaces, you might hear your voice bounce back after a short delay. The reflection of sound is used in many applications, from sonar in submarines to architectural acoustics in concert halls. Echo occurs when a sound wave reflects off a distant surface and returns to your ears after a delay. For an echo to be heard, the reflecting surface must be at least 17 meters away from the source. Echoes are not just a curiosity, they have practical uses in measuring distances and in technologies like sonar and ultrasound. Understanding echoes helps us appreciate how sound interacts with our environment. Reverberation is the persistence of sound in a space after the original sound is produced. Unlike an echo, which is a distinct repeat, reverberation is a series of overlapping reflections that blend together. This is why your voice sounds different in a small room compared to a large hall. Controlling reverberation is important in designing auditoriums and studios to ensure clear sound quality. Not all sound is reflected. Some of it is absorbed by materials. Soft materials like curtains, carpets, and foam absorb sound waves, reducing echoes and reverberation. This is why recording studios and theaters use special materials to control sound. The absorption of sound is crucial for creating comfortable and functional spaces, whether it's a classroom or a concert hall. Sound has several important characteristics: pitch, loudness, and quality or timbre. Pitch is how high or low a sound is, loudness is how strong or weak it is, and quality is what makes one sound different from another, even if they have the same pitch and loudness. These characteristics help us distinguish between different musical instruments or voices. Pitch refers to how high or low a sound seems to us. It depends on the frequency of the sound wave. The higher the frequency, the higher the pitch. For example, a whistle produces a high-pitched sound while a drum produces a low-pitched sound. Musicians use pitch to create melodies and harmonies, and our ears are finely tuned to detect even small differences in pitch. Loudness is how strong or weak a sound is, and it depends on the amplitude of the sound wave. A larger amplitude means a louder sound. Loudness is measured in decibels, dB. Everyday sounds range from a whisper at about 30 dB to a rock concert at over 100 dB. Protecting our ears from very loud sounds is important for maintaining good hearing health. Quality, also known as timbre, is what makes each sound unique. Even if two instruments play the same note at the same loudness, they sound different because of their timbre. This is due to the presence of overtones and the way sound waves combine. Timbre allows us to recognize voices, musical instruments, and even different brands of the same instrument. Frequency is the number of vibrations per second, measured in Hz Hz. Wavelength is the distance between two consecutive compressions or rarefactions in a sound wave. These two properties are closely related. As frequency increases, wavelength decreases. Understanding frequency and wavelength helps explain why different sounds have different pitches. Amplitude is the maximum displacement of particles from their rest position in a sound wave. It's directly related to the energy carried by the wave. The greater the amplitude, the more energy the sound wave has and the louder it sounds. This is why a gentle tap sounds soft while a strong knock is loud. Amplitude is a key factor in understanding loudness and energy transfer in sound. Human ear is a remarkable organ that detects sound waves and converts them into signals our brain can understand. It consists of three main parts: the outer ear, middle ear, and inner ear. Each part plays a crucial role in capturing, amplifying, and interpreting sound. Understanding the ear's structure helps us appreciate how we hear and why hearing protection is important. Sound waves enter the outer ear and travel down the ear canal, causing the eardrum to vibrate. These vibrations are passed through tiny bones in the middle ear which amplify the sound. The inner ear then converts these vibrations into electrical signals that are sent to the brain. This complex process allows us to perceive a wide range of sounds, from a whisper to a thunderclap. Humans can hear sounds in the frequency range of about 20 Hz to 20,000 Hz. Sounds below 20 Hz are called infrasound, while those above 20,000 Hz are called ultrasound. Our sensitivity to different frequencies varies, with the greatest sensitivity between 2,000 and 4,000 Hz. This range allows us to enjoy music, communicate, and detect important sounds in our environment. Ultrasound refers to sound waves with frequencies above 20,000 Hz which are beyond human hearing. Infrasound refers to frequencies below 20 Hz. Both types of sound have important applications. Ultrasound is used in medical imaging and cleaning, while infrasound is used in studying earthquakes and animal communication. These sounds reveal the hidden world beyond our hearing. Ultrasound has many practical uses. In medicine, it's used for imaging internal organs and monitoring pregnancies. In industry, ultrasound is used for cleaning delicate objects and detecting flaws in materials. The ability of ultrasound waves to penetrate materials and reflect off boundaries makes them valuable in both healthcare and engineering. Not all sounds are pleasant. Noise is unwanted, irregular sound, while music is organized and harmonious. The difference lies in the regularity and pattern of the sound waves. Music has a pleasing effect on our minds, while noise can be disturbing and even harmful to health. Understanding this distinction helps us appreciate the role of sound in our lives. Noise pollution is a growing problem in urban areas. It comes from traffic, construction, factories, and loudspeakers. Prolonged exposure to high noise levels can lead to stress, hearing loss, and other health issues. Controlling noise pollution is important for maintaining a healthy and peaceful environment. Simple measures like planting trees and using sound barriers can help reduce noise. Sound is measured using instruments like the sound level meter. The unit of loudness is the decibel dB. Measuring sound levels helps us monitor noise pollution and ensure safe environments in workplaces, schools, and public spaces. Accurate measurement is essential for setting regulations and protecting our hearing. Excessive noise can have serious health effects. It can cause hearing loss, increase stress levels, disturb sleep, and even affect heart health. Children and elderly people are especially vulnerable. Being aware of these risks helps us take steps to protect ourselves and others from the harmful effects of noise. Protecting our ears from loud sounds is essential for long-term hearing health. Simple steps include using earplugs in noisy environments, turning down the volume on headphones, and taking breaks from loud activities. Schools and workplaces should also follow safety guidelines to minimize exposure to harmful noise. Echoes are not just a classroom concept, they occur in nature too. Bats and dolphins use echoes to navigate and find food, a process called echolocation. By emitting sounds and listening for the echoes, these animals can detect objects and prey even in complete darkness. This natural use of sound waves is both fascinating and vital for survival. SONAR stands for Sound Navigation and Ranging. It uses sound waves to detect objects underwater. Ships and submarines send out sound pulses and listen for echoes to map the ocean floor or locate other vessels. SONAR is a powerful example of how understanding sound can lead to important technological advances. Hearing aids are devices that help people with hearing loss. They amplify sound, making it easier to hear conversations and everyday noises. Modern hearing aids use advanced technology to filter out background noise and focus on important sounds. These devices greatly improve the quality of life for millions of people around the world. Musical instruments produce sound in a variety of ways by vibrating strings, air columns, or membranes. Each instrument has its own unique sound or timbre based on how it produces and amplifies vibrations. From guitars to flutes to drums, understanding the science of sound helps musicians create beautiful music. String instruments like guitars and violins produce sound when their strings vibrate. The pitch depends on the length, thickness, and tension of the string. Musicians can change the pitch by pressing the strings or tuning them. The body of the instrument amplifies the sound, making it louder and richer. Wind instruments like flutes and trumpets produce sound by vibrating columns of air. The pitch is changed by opening or closing holes or valves, which changes the length of the air column. The shape and material of the instrument also affect the quality of the sound. Wind instruments are a key part of many musical traditions. Percussion instruments like drums and xylophones produce sound when struck. The vibration of a membrane or solid surface creates sound waves. The size, shape, and material of the instrument affect the pitch and loudness. Percussion instruments add rhythm and excitement to music, making them essential in many styles. Resonance occurs when an object vibrates at its natural frequency due to an external sound. This amplifies the sound, making it louder and richer. Musical instruments use resonance to enhance their sound. However, resonance can also cause problems, such as when bridges or buildings vibrate dangerously during earthquakes. The Doppler effect is the change in frequency or pitch of a sound as the source moves relative to the listener. You've probably noticed this when an ambulance passes by. The siren sounds higher as it approaches and lower as it moves away. This effect is used in radar, astronomy, and even weather forecasting. The Doppler effect has many practical uses. Police use it in speed guns to catch speeding vehicles. Meteorologists use it to track storms, and astronomers use it to study the movement of stars and galaxies. This simple principle of sound waves helps us in many fields, from law enforcement to space exploration. We encounter echoes in many places: empty halls, mountains, and even in our own homes. Architects use knowledge of echoes and reverberation to design spaces with good acoustics. Understanding how sound reflects and travels helps us create comfortable and functional environments. Acoustics is the science of sound and its behavior in different environments. It involves controlling reflection, absorption, and transmission of sound to achieve the desired effect. Good acoustics are essential in theaters, auditoriums, and recording studios. Engineers use principles of acoustics to design spaces that enhance sound quality and reduce unwanted noise. Soundproofing is the process of preventing sound from entering or leaving a space. It involves using materials that absorb or block sound waves, such as foam panels, carpets, and double-glazed windows. Soundproofing is important in recording studios, offices, and homes to ensure privacy and reduce noise pollution. Sound travels much faster in water than in air. This is why whales and dolphins can communicate over long distances in the ocean. Underwater sound is used in navigation, communication, and exploring the deep sea. Understanding how sound behaves in water opens up new possibilities for science and technology. Sound travels fastest in solids because particles are packed closely together. This is why you can hear a train coming by putting your ear to the track before you hear it in the air. Engineers use this property to detect faults in structures and materials. Sound in solids is an important concept in both science and engineering. Most of the sounds we hear travel through air, which is a gas. The speed of sound in air is affected by temperature, humidity, and pressure. Warmer air allows sound to travel faster. Understanding sound in gases helps us explain everyday phenomena like thunder and the way voices carry over distances. We've covered the essentials of sound for ICSE Class 10, from how it's produced and travels to its characteristics and applications. Understanding sound helps us in science, technology, and daily life. Remember the key points: sound is a wave, needs a medium, and has properties like pitch, loudness, and quality. Applications range from music to medicine to engineering. Congratulations on completing this journey through the world of sound. With a solid understanding of the concepts covered, you're well prepared for your ICSE Class 10 exams. Keep exploring the wonders of sound in your daily life and studies. Science is all about curiosity and discovery, and sound is just one of the many fascinating topics waiting for you.